Right, B is a little bit easier. For B, we don't have any horizontal stretches or shrinks. I'm just going to make our math a little easier. Again, I'm going to work left to right. My negative out front is going to be a reflection over the x-axis. I'm going to do myself a little sketch for what sine is going to look like then. So sine usually looks like a wave. And if we reflect that over the x-axis or over the y-axis, my wave is going to go down and then up. So here's what I'm going to start with. That's what I'm going to do transformations to. The 3 out front is going to give us an amplitude of 3. It's a vertical stretch by 3 if we're thinking transformation rules. I don't have a number in front of x. So the period is 2 pi. There's no change to the period of the function. If you are in the habit of always doing 2 pi divided by the number in front of x, here your number in front of x is just 1. No vertical displacement because we don't have any numbers out front. We do have a phase shift. So since we don't have a number out front here, you can still think of your phase shift as always c over b, b being your number in front of x. But here, that would just be pi over 2 divided by 1, which is pi over 2. And since it's a negative pi over 2, it's pi over 2 to the right. So when I'm doing this graph, sorry about the bell again. When I'm doing the graph, I'm going to start, instead of at the origin, I'm going to start pi over 2 to the right. The period of my function is 2 pi. So from here, I'm going to go 2 pi. That's going to be out at 5 pi over 2. I'm just moving everything 2 boxes to the right. All right. Sorry, I had to pause for announcements there. So we moved pi over 2 to the right. We have a period of 2 pi. And now we need to do our amplitude of 3. So, well, actually, when we go back to our main graph here, so we have those 2 spots placed. Halfway in between is where we cross our x-axis or our midline. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 boxes. So 4 boxes out, I can do my midline there. And then halfway in between, I'm going to have a minimum and a maximum. So again, I started at pi over 2 since we moved pi over 2 to the right. Now I can draw my curve. And you can finish that pattern out. Again, you have a dot every 2 boxes here. You need to double check that your amplitude is 3 when you're done. That's a really easy thing to forget or to change as you are drawing your graph. Make sure you fill your paper. All right, our domain is all reals. And our range is -3 to 3. Part C says find the inverse of B and state the domain. All right, so I'm just going to recopy our function there. The function we're working with is y equals -3 sine of x minus pi over 2. So a little inverse review. To find the inverse, we switch x and y. And then solve for y. So the first thing I'm going to do is divide by that -3. And I don't care where you put that in negative, it's all equivalent. And then to undo sine, we do sine inverse or arc sine. So I'm going to take arc sine or sine inverse of both sides. You can write it either way. And that cancels the sine. You can't move over the pi over 2 until you take the inverse of sine. That's absolutely critical. Stick that negative somewhere. And then you want to add over your pi over 2. And that is your inverse. Usually we mark that as f to the negative 1, especially if we had defined that, or if we define that original as f of x. So remember, once we find the inverse, we also need the domain. And the special thing about inverses is that all of their x's and y's are switched. So if you want the domain of the inverse, you just grab the range of the original. I'm not going to be asking you for the range. I'm not going to be asking you for the range of the inverse without a calculator. That's something that you remember, you have to restrict the domain from the beginning, and I wouldn't expect you to do that without a calculator. But finding the domain of the inverse is absolutely reasonable. All right, so that is 3, B, and C.